Hello, everyone. I am Dr. Anup Narayanan, Associate Professor in the Department of Pharmaceutics at NGSM Institute of Pharmaceutical Sciences. In this session, we will discuss an important separation technique used in pharmaceutical and chemical industries, that is, flash distillation. Let us begin with the basic concept. Flash distillation is a process in which an entire liquid mixture is suddenly vaporized. This is achieved by passing the feed from a high pressure region to a low pressure region, causing instantaneous vaporization. It is also known as equilibrium distillation because the separation occurs when the vapor and the liquid phase reach the equilibrium. Unlike fractional distillation, this process does not involve rectification and is commonly operated as a continuous process. The principle of flash distillation is based on sudden pressure reduction. A hot liquid mixture is introduced into a chamber maintained at low pressure. This sudden drop in the pressure results in what we call flash vaporization. During this process, the system experiences cooling, vapor, and liquid phases remaining in close contact. Equilibrium is established. Separation occurs due to differences in relative volatility of the components. When flash vaporization occurs, it absorbs energy, leading to cooling of the system. As a result, high boiling components condense and remain in the liquid phase. Low boiling components stay in the vapor phase, and the two phases are allowed to remain in contact long enough to reach the equilibrium. Finally, the vapor and the liquid fractions are separated and collected independently. The flash distillation setup consists of the following key components: a pump which transfers the feed from reservoir, a heater which raises the temperature of the liquid mixture, a reducing valve which creates the sudden pressure drop, a separator chamber which phase separation occurs, and the separator is designed such that vapor exit from the top outlet and liquid is collected from the bottom outlet. The feed is introduced directly into this chamber. Let us now understand the working of flash distillation step by step. Pumping the feed is the pumped at high pressure. Heating, the liquid is heated to desired temperature. Flashing, the pressure is suddenly reduced using a valve. Equilibrium, vapor and liquid phase reaches the equilibrium. Then the collection, where vapor is collected from the top and the liquid from the bottom. This sequence ensures efficient separation of the components. In industrial applications, flash distillation is usually carried out under steady state conditions. This means the feed rate is equal to the output rate, and the composition of vapor and liquid remains constant over time. Such control allows for continuous operation, process optimization, high throughput in large scale systems. Flash distillation is primarily used for separating components with significantly different boiling points. One of its major application in the petroleum industry is practically in the crude oil refining. Some key advantages include continuous and efficient operation suitable for multiple component systems, effective for petroleum fractions with narrow boiling range. These petroleum products are often waxes and other components which are used in pharmaceuticals as the base materials for preparation of various pharmaceutical formulations. Despite its advantages, flash distillation has certain limitations too. This is not effective for components with very similar volatility. It is generally unsuitable for simple binary mixtures and it cannot be produced for highly pure components. The separated fractions are often not completely pure, therefore, it is mainly used when rectification is not required. With this, we are coming to the end of this session on flash distillation. I hope this lecture has helped you to understand the principle, working, and applications of the process. Thank you for your attention, and we are providing you the reading materials, questions, and practice exercises for your better learning and understanding in this module as well as on other topics. Please go through the same and revise yourself and make sharpen your knowledge on various distillation processes. Thank you once again.